Thank you for joining today's webinar on managing modern applications at scale. My name is Isaiah Salinas. I'm a senior solution architect for the management tools. And today we're going to talk about managing our modern applications at scale. And just to start off, we're going to go over a brief overview of what is modern applications. What do our customers want in a modern application? Well, many of our customers want to become more agile so they can innovate and respond to change faster. The application that organizations need to build today are vastly different than what they had in the past. They need to scale quickly to potentially millions of users, have global availability, manage petabytes, if not exabytes of data, and respond in milliseconds. These type of applications are what we call modern applications. They cover use cases such as web and mobile backends, IoT applications, AI, ML workloads, batch processing, platform as a service solutions, and microservices backends, and much more. However, customers then tend to ask, how do you manage modern applications? What are some of the challenges that customers face? Well, in order to manage modern applications, they need to have a visibility into their application. They need a process to where they can automate their configuration and management of their applications. And lastly, they need some mechanism to apply configuration compliance to maintain configuration state of their application resources. Today, we're going to briefly talk over various AWS services that can help in managing our modern applications. Let's first talk about Amazon CloudWatch and AWS X-Ray. Within Amazon CloudWatch, we have Container Insights. Container Insights allow us to collect, aggregate, and summarize metrics and logs from your containerized applications and microservices. Container Insights is available for Amazon Elastic Container Services, Amazon Elastic Kubernetes Services, and Kubernetes platforms on Amazon EC2 and ECS. The metrics include utilization for resources such as CPU, memory, disk, and network. Container Insights also provides diagnostic information such as container restart failures to help you isolate issues and resolve them quickly. You can also set CloudWatch alarms on metrics that Container Insights collects. Another service is AWS X-Ray. AWS X-Ray helps you to easily analyze and debug modern applications built using microservices and serverless architecture. This is achieved by collecting data about the requests from each of the underlying application as it passes through the stack. X-Ray then combines this data into a singular unit called traces. Customers who use AWS X-Ray can then, through the service map, see relationships between services and resources in your application in real time. You can easily detect where high latencies are occurring, visualize node and edge latency distribution for services, and then drill down into the specific services and paths impacting application performance. Lastly, it is then possible to quickly drill into the service that is showing unusual behavior in order to identify the root cause of the issue. Additionally, we have 3 other services that were recently launched. One is AWS Distro for OpenTelemetry. This allows you to install this service within your container and AWS Lambda consoles. This allows you then to export various metrics to different monitoring mechanisms such as CloudWatch, X-Ray, Elasticsearch services, and also Prometheus. When it comes to Prometheus, one of our newest services is Amazon Managed Services for Prometheus. This allows us to collect and query metrics from AWS container services, including Amazon EKS, Amazon ECS, and AWS Fargate. Amazon Managed Services for Prometheus also includes an API that makes it easier to securely ingest and query metrics from self-managed Kubernetes clusters running on AWS or on premises or anywhere Kubernetes is supported. Some of the use cases that you can use Amazon Managed Service for Prometheus is to monitor containers running on Amazon EC2, ECS, and EKS, as well as on-premise and other cloud providers. Using it together with Amazon Managed Services for Grafana for monitoring, alerts, and dashboard views across all your Kubernetes environments. Along with the AWS distro for OpenTelemetry, you can collect and monitor metrics from anywhere. Prometheus libraries of open source exporters for many popular application stacks can also be used to send those metrics to Amazon Managed Services for Prometheus, which can receive the metrics and be used to query them. You can use open source Prometheus exporters to monitor application metrics such as latency and errors, and infrastructure metrics like CPU and memory usage. You can also bring custom metrics into Amazon Managed Services for Prometheus and annotate them with trace IDs. Amazon Managed Services for Prometheus provides host-level monitoring for the host that containers is running on, as well as any VMs or EC2 instance. We also have a service that's currently in preview called Amazon Managed Services for Grafana. This is a fully managed, rich, interactive data visualization service that is scalable, secure, and high available. You can analyze, monitor, and alarm on metric, logs, and traces across multiple data sources, including AWS, other cloud providers, third-party ISVs, and databases. With these services from Amazon CloudWatch, X-Ray, it allows us to gain visibility into our modern application. However, one thing that is needed also is configuration compliance. And this is where AWS Config can help us meet that criteria. With AWS Config, it allows us to assess, audit, and evaluate the configuration of your AWS resources. Config continuously monitors and records your AWS resource configuration and allows you to automate the evaluation of recorded configuration against desired configuration. With Config, you can review changes in configurations and relationships between AWS resources, dive into detailed resource configuration history, and determine your overall compliance against the configurations specified in your internal guidelines. This enables you to simplify compliance auditing, security analysis, change management, and operational troubleshooting. With AWS Config, it provides you a way to put in automatic remediation for the config rules that you set on your resource. This allows you to select from a list of provided system management automation documents to put back in the configuration of your resource when it goes off your configuration state. You can invoke these remediations from either through the console or via the API. Now, to help us provide the automation within our modern application, the automation that's needed to keep our infrastructure at a desired state, we'll utilize AWS System Manager. The goal behind AWS System Manager is to help you shorten the time to detect problems. It provides mechanisms to ease the process of automating workflow within your AWS infrastructure. And it does this in 3 key areas. First, it groups your resource in a way that's meaningful to you and your environment. It can do it by application, environment, or business unit, Basically, whatever that makes sense to manage your resources from an operational perspective. It then will visualize that data, then take action to respond to specific areas where you need to automate the operation actions across your infrastructure. With AWS System Manager, it provides many various capabilities, which we're shortly going to dive into many of these areas to help us manage our modern applications. For an example, we can use automation to allow us to automate certain steps involved to handle and manage our application resources that we have. AWS SSM also provides the run command, where it allows us to initiate scripts within our actual instances where we can automate the process of managing our instances. We'll look into inventory, where inventory will allow us to collect the information that is currently installed on our EC2 instances to provide a compliance information to where we can manage what is being installed in our instances. So let's go over a brief demo on how we can actually manage a modern application. We're going to look into container insights, how we can use those. We're going to look into X-ray, how can the traces help us? And then how does SSM and AWS Config then tie in together to provide the automation, configuration compliance, and manageability of our environments? So in our demo, we have already deployed a modern application of a sample website that's running on EKS. And this is an application of our cute little pet seeking a home. As you can see, we have an application that provides many functionalities on a modern web application where we can click on various areas in here. And we can go ahead and initiate one of these functions that basically does an adoption. So what I did is I basically did a process of the application from what an end user would see in a website and going through the process of adopting a pet in this website. Behind the scenes, then we have our Amazon CloudWatch agent running on our EKS nodes that's collecting all that metrics and information, where we can then visualize that and see what's actually going on within our environment. So if we go into Amazon CloudWatch under Container Insights, we can actually see our various resources that we have running for our modern application of the website of the pets. Let's take a look at our pet site here, our EKS cluster. Within our EKS cluster, we're going to go ahead and click on that one. And it's going to provide us various visualization graphs of different metrics that Container Insights is catching within our EKS cluster, such as CPU utilization, memory utilization, networking, disk utilization, and other metrics. This allows us to gain visibility as far as how our application is actually performing. With these metrics, we can then put in place various alarms to then send us alert notification via SNS, and also additionally enable it to create an SSM ops item that can then notify us of specific operational issues that are occurring within our application. We're later going to see how we can actually leverage SSM ops item, an ops item within Ops Center to help us with this operational troubleshooting. Another area that we discussed was AWS X-ray. AWS X-ray allows us to gain traces of our usage of our application. So if we look into AWS X-ray under traces, we can see various traces that are being captured as far as the time taken from the user clicking on a specific area within our application on our website and how long it took for them to process that specific step. This helps us troubleshoot if there's any latency, if there's any issues or errors that occur within the process of a user actually using our application. Let's take a look at some of them. So we'll go ahead and look at our response time here and drill down further. And we see some in here that are different response times. So we'll take this one that is at 48 milliseconds. This then provides us a nice map overview as far as the entire process that a user initiated within our website and the various services that it actually went through to return the results for the actual user. Down below, we have the various methods that were being called, and also will display if any errors are actually located. So let's take a look at a trace that actually has an error. So I'm going to go and take a look at this one that was a high latency response time of 71 milliseconds. So we'll go and look at that one. And down below, as it gives the various steps involved, you'll notice that each one of them has a green check mark indicating no errors. But we'll find one here that actually gave us an error of an access denied. This is where X-Ray can help us identify and troubleshoot specific issues within our application, where we can then dive in deeper into this information and see what actually occurred, what was the operation, and any other additional information that we would need to help us troubleshoot this specific issue that happened within our application. So a good example how AWS X-Ray can help us with traces to identify specific issues within our application. As I mentioned, with Amazon CloudWatch, we can enable alarms that allows us to alert us when specific thresholds are being met within our metrics. For an example, our CPU utilization. If this were to go high, it needs to alert us via an email or some type of notification. So let's take for an example of a high CPU load. I'm going to go into AWS Systems Manager, and I'm going to simulate a high CPU load. And one of the nice things with AWS Systems Manager, it also provides an option where you can use Session Manager to allows you to SSH into your instances that you have to run any operational issues that you need to do within the actual instance itself. So I'm going to go ahead and use Sessions Manager and connect to one of my EKS nodes. So let's go ahead and simulate a high CPU. So I'm going to run a tool called Stress. And this is going to cause some high CPU utilization within my EKS node. And the purpose of this demonstration, I want you to show you how I have a CloudWatch alarm that's currently detecting high CPU utilization on my node. And if it turns into an alarm, it's automatically going to set up and create an ops item for me in SSM Ops Center. So we'll go to SSM. And under Ops Center, we'll see we already have one ops item that was created. It was due to a CloudWatch alarm of high CPU. If we click on that ops item, we then are able to analyze different operational data that was captured via Ops Center. Here we see how we have the resources that were involved, and we can see here the EC2 instance that generated that high CPU load. It will also provide us any additional information such as similar operation items that have occurred in the past. This will provide us a history if this specific instance or resource has had other operational issues in the past, and help us drill down to get a history of these items. Up above, we have related resource details, which can provide us some overview as far as our visualization of our CPU utilization over time for this specific resource, and give us some operational data as far as how was this instance performing. We can then, with this ops item, then take specific action as far as how to remediate this resource. And this is where we're going to use what SSM has is called automation documents, our runbooks. There's various automation documents already provided for us that we can use for operational troubleshooting. So for this particular example, there is a runbook, an automation document called Restart EC2 Instance. I'm going to go ahead and initiate this to go ahead and restart that instance. It automatically will pass the instance ID related to that resource that was having the high CPU utilization issue. I'll go ahead and execute that automation document. And what this is going to do is basically SSM is going to initiate that run document against that instance. It's then going to apply a reboot. The instance is then going to reboot. And hopefully that will then put back into a good state or alarm with that high CPU utilization. So this is an example how you can leverage your visibility using CloudWatch and then alert you when any metrics go past a threshold, and utilize SSM to create an ops center ops item where you can then take specific action utilizing SSM run documents to remediate your resource. So now let's take a look at some additional areas where SSM can help us manage our modern application through automation. So when we discussed the Ops Center Ops item, we ran an SSM runbook, which initiated an SSM document. These documents are located within SSM. And SSM provides various amounts of AWS managed documents that can be used to run specific actions against your EC2 instances or AWS resources. These documents can be used, for an example, within your Ops Center. You can also use these documents within SSM run document and also SSM automation to initiate specific actions against your instance that's managed by SSM. You can also create your own document that will do specific tasks that you can outline that you want to run against or automate within your instance. One area that we want to talk about is SSM State Manager. SSM State Manager is used to be able to put in a specific configuration state your instance. Let's say, for example, you want to keep up to date specific agents running within your EC2 instance. You can use SSM State Manager to create an association that will run specific documents that will update or install specific agents on your instance. For an example, here we have some association where it updates the CloudWatch agent, or also keeps up to date the SSM agent. Other examples where we can utilize SSM State Manager is to run specific tasks, for example, gathering software inventory that can provide us a collection of what's currently installed on your EC2 instance. Let's take a look how we can actually create an association to apply a specific configuration state against our EC2 instance. We'll click on Create Association. We'll give it a name. Here we're going to go ahead and associate a specific document with an SSM that we want to run. As mentioned previously, there are various provided AWS managed documents. In this example, we're going to use a document called AWS Run Shell Script. So we'll go ahead and I'm going to select this document. And what this document allows me to do, it allows me to provide specific commands that are going to run against the managed instance via SSM. This allows me then to automate and run specific commands where I want to apply specific configuration within my instance. So we're going to go ahead and type in a command that basically will configure my EC2 instance to enable an additional repository for my instance. So I'll paste in the command there. And then down below, you then want to define the targets where this association is going to be applied to. We have several ways we can do this. We can do it by defining a specific tag, key, and value, or we can actually choose the instance manually, or use an existing resource group that defines specific instances that we're going to run this association against. We also have the option where we can select and choose all instances currently managed by SSM within this region. For this example, we're going to go ahead and utilize specifying an instance tags. And we're going to put the tag key and value of our instances within our EKS cluster. So I'll put in my tag key there with my tag value of my pet site. I'll go ahead and click on add. And then next it wants for us to define a schedule. This is going to be the schedule where SSM is periodically going to check to make sure that the specific configuration state that we're defining with this association is met. If it is not, it's going to run that specific document, which I outlined previously, with that specific script that I put in place. So we're going to go ahead and then click on Create Association. We can see here our association was created. It's in a pending state. At this point, it's going to then apply it to the specific instances where we defined on the tag key and tag value. So wait a bit to see when it gets ran. Let's go ahead and refresh it. As you can see here, the demo state association that we just created was successful. We can actually look at this association and grab specific information around this association that we defined. If I go to execute history, I can see the execution ID and the status was a success. So utilizing State Manager with SSM is a way where we can automate specific configuration for our instances that is running our modern application. In this example, our pet's website within our EKS cluster. We can utilize State Manager to apply specific configurations, install specific software within our instance, or also updating existing agents that are running within our EKS nodes. As mentioned previously, SSM is able to also gather specific software inventory within our instance. In Fleet Manager, we can actually take a look at what specific software information is being gathered within our instances that are currently managed with SSM. Here we have our instance. We'll go ahead and select it. And we'll see a tab here called Inventory. Here it's going to find the various software inventory that is being collected by SSM. This information is useful because later when we discuss AWS Config, with AWS Config, we can actually apply a config rule that checks against the software inventory that's gathered by SSM and allows us to put a rule in place whether or not a specific software name or version is permitted to be installed within our instance, or perhaps we have a specific software name and version we do not want installed within our instance. This is where we can utilize the information gathered by SSM together with AWS Config to keep into a specific configuration compliance state our instances within our application. Now let's take a look at AWS Config and how it can help us with this configuration compliance to keep it in a specific state of compliance for our application that we are running. So we'll go ahead and click on AWS Config here. We'll go to the AWS Config console. Now in AWS Config, it allows us to keep this configuration compliance state by defining AWS config rules. With AWS config rules, you can set your specific configuration compliance, such as security groups, if you only want to allow specific ports on security groups. When it comes to our EKS nodes, is a specific EKS required version that you need to be set within your EKS cluster. You can use AWS Config to monitor this configuration compliance. With our config rules, you can then also apply remediation. As I mentioned before, you can apply this auto remediation to go ahead and put back into the correct state of your resources utilizing remediation actions. Let's take, for example, we have this config here rule here, which is restricted common ports. What this config rule is basically checking our security groups for any open access public rules that is allowing public access rules to the internet. If it detects any of these rules in place, it will then mark non-compliant those security groups. So let's go and look into this restricted common ports rule. As you can see here, these are the ports that I'm checking to make sure there's no open access rule allowed publicly to the internet. And down below, it did flag a security group that has an open access rule to the internet on one of these ports. Let's go ahead and take a look at that. So I'm going to go back to my EC2 console here. This is the security group that was in question. If you notice, there is an open access rule for port 3389. Now, how can AWS Config then help us manage the configuration state? Well, it can do it by utilizing the auto remediation. If I go ahead and click on this security group, I have a button here that says remediate. Now, what this is going to do, it's going to utilize SSM and run an automation document called AWS Disable Public Access for Security Group. Now, there's many automation documents that are currently provided and managed by AWS. Many of these can fit your specific use case. However, you do have the option to build your own custom automation document to outline the series of steps that you need to apply in order to remediate your resources. For this example, I'm going to go ahead and use this provided AWS managed automation document called Disable Public Access for Security Group. I'm going to go ahead and select my security group and click Remediate. This is then going to go ahead and trigger that automation document, run the series of steps needed to go into that security group, look for specific rules on those ports. If it sees an open access rule, it's going to go ahead and remove that rule and basically mark that specific resource back into compliance. Let's go back to our EC2 console and look at the security group. We're going to go ahead and refresh this security group, and we want to see if this actual public access rule is now removed. As you can see here, it was now removed. The only open access role is port 80, which is needed for our website. So one example here on how AWS Config can help us keep our configuration compliance and to manage our configuration state for our applications. So in a review, we were able to see various services that AWS does provide that allows us to manage our modern applications. We're able to see how we can utilize container insights and enable alarms via metrics that initiate an Op Center item, where we then able to utilize SSM run documents to remediate those resources that had operational issues. We then were able to see how we could utilize AWS Config to keep a configuration compliant state of our resources that our application uses. So many of these steps that I did through the demo are provided for you that you can actually run through. And we have 2 workshops that allows you to get familiar with many of these services, such as Container Insights, X-Ray, OpenTelemetry, Amazon Managed Prometheus, Amazon Managed Grafana, SSM, AWS Config. And these are the various workshops we have that you yourself can go to and run through the various labs that are provided. And this will give you a nice overview on how you can utilize these services to help you manage your modern applications. We hope you enjoyed today's webinar, and we thank you for coming.